Assalamualaikum warahmatullahi wabarakatuh.
Assalamualaikum warahmatullahi wabarakatuh.
Peace be upon you.
Good morning, and we are delighted to welcome you to the first international conference on industrial automation smart grid and its applications, ICIASGA 2020.
And to the first international conference on economics, business and social humanities, ICONEBS 2020.
Hosted by State Polytechnic of Madiun, East Java, Indonesia. My name is Alif.
And my name is Ita. We are in charge as your MC for this opening ceremony for this international conference. To the Honorable Mr. Muhammad Fajar Subhan, STMT, as the Director of State Polytechnic of Madiun,
Distinguished guests and all of participants of the conference. Today, we have more than 80 participants are joining in this online international conference, and many of them come from different parts of these regions and also from abroad.
on behalf of the organizing committees, we thank you all for participating in this conference.
Ladies and gentlemen, we would like also to express our sincere gratitude to plenary speakers, without whom we won't have this meaningful event.
Our thanks go to Professor Ahtar Kalam from Victoria University, Mr. Wahyu Kaisarendra, PhD, from University Brunei Darussalam, and also Associate Professor Dr. Hasliza Arahim from University Malaysia Perlis.
Our thanks also go to Associate Professor Dr. Meller Muhammad Yunus of National University of Malaysia, Lieutenant Commander Dr. Abu Yazid bin Abu Bakar TLDM of University Kebangsaan Malaysia, Mr. Dani Ridwan, Ministry of Finance of the Republic of Indonesia. Great appreciation to Aviation Polytechnic of Surabaya and Polytechnic of Jambi for co-hosting the conference as well.
Ladies and gentlemen, first of all, let us read the sequences of agendas in this opening ceremony as follows. The first, singing national anthem, Indonesia Raya. The second, dua recitation. And the third, traditional dance performance by students of State Polytechnic of Madiun.
Fourth, welcoming speech from the General Chair of Conference. Fifth, welcoming speech as well as officially opening speech from the Director of State Polytechnic of Madiun.
Ladies and gentlemen, let's begin our first agenda by singing national anthem. To all of the audiences, please stand up.
To all audiences, please sit down And we are going to continue to the next agenda, the recitation of dua, led by Mr. Dahris Sahab. To Mr. Dahris, time is yours.
Assalamualaikum warahmatullahi wabarakatuh. Ladies and gentlemen, good morning, selamat pagi, selamat sejahtera buat kita semua. Ladies and gentlemen, let us bow our head for a moment. Pray to God Allah Subhanahu wa Ta'ala, so that our international conference can be precious to all of us. I will lead this prayer based on the teaching of Islam. And those who are not Muslim, you are pleased to pray according to each of your beliefs. A'udzu billahi minasyaitonir rajim. Bismillahirrahmanirrahim. Allahumma salli ala sayyidina Muhammad wa ala ali sayyidina Muhammad. Alhamdulillahi rabbil alamin. Hamdan yuafi ni'amahu kafi mazidah. Ya Rabbana lakal hamdu kam bagi jalali wajhika wa azimi sultanik. Allahumma inna nas'aluka salamatan fid dinina wa afiatan fil jasadina wa ziyadatan fil ilmina wa barakatan fil rizkina. Allahumma ighfir lana wa liwalidayna walil muslimin wal muslimat wal mu'minin wal mu'minat al ahya'i minhum wal amwat innaka sami'un qaribun mujibud da'awat ya qadiyal hajat. Ya Allah, today Wednesday, November 4th, 2020, in this beautiful place, we gather here to bring about the first international conference on industrial automation, smart grid, and its application, and the first international conference on economics, education, business, and social humanities. Make this international conference as a useful science assembly, as a medium of sharing useful ideas, knowledge, and experiences of scholars, researchers, and students of various disciplines. May the conference we organize today benefit to our life, broaden our knowledge, shine our ideas, and lead us to be successful, productive persons with intel will boost dignity of our nation. Ya Allah, guide and bless our hearts and our mind with the light of your guidance. Impart your supreme wisdom upon our activities. Help us to speak our minds clearly. Help us to listen to each other, respect each other, love each other, so that we are included to the blessed persons. Ya Allah, protect us from unintended temptation, show us the right paths, and give us knowledge and strength to perform good things. Equally, show us and make it clear the bad things, and give us knowledge and strength to avoid them. Ya Allah, you are the one who can fulfill our prayer. Rabbana atina fid dunya hasanah wa fil akhirati hasanah wa qina azabannar. Subhana rabbika rabbil izzati amma yasifun wa salamun alal mursalin walhamdulillahi rabbil alamin. Amin 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 ya rabbal alamin. Assalamualaikum warahmatullahi wabarakatuh.
Ladies and gentlemen, for the next session of this conference is the performance traditional dance by students of State Polytechnic of Madiun. What a great performance. Madiun City is also known as Kota Pendekar, home of ASEAN warriors.
Yeah, great. Before continuing to the next agenda, I would like to invite the Director of State Polytechnic of Madiun and the General Chair of ICIASGA and ICONEBS 2020 to come forward to the stage, please. Thank you very much. And now we are going to invite the most responsible person to this meaningful event, the General Chair of ICIASGA and ICONEBS 2020, to the Honorable Mr. Nur Asik. Time is yours.
Good morning, ladies and gentlemen, keynote speakers, and all participants. Assalamualaikum warahmatullahi wabarakatuh. Welcome to the International Conference on Industrial Automation, Smart Grid and its Application, ICIASGA, and the International Conference on Economic, Business and Social Humanities, ICONEBS 2020. The first international conference held in State Polytechnic of Madiun. The theme for this conference is Green Technology and Energy 5.0, and the dynamics of economic, business and social humanities. As we might be aware that the World Health Organization officially declared the COVID-19 a pandemic, governments around the world are now issuing restrictions on travel, gatherings and meetings in an effort to limit and slow the spread of the viruses. And the health and safety of the author, keynote speakers and all research communities is our first priority, and we are supporting these efforts. Therefore, the ICIASGA and ICONEBS conference today is held virtually during 4 and 5 November 2020. Ladies and gentlemen, the ICIASGA and ICONEBS conference is hosted by State Polytechnic of Madiun and co-hosted by Aviation Polytechnic of Surabaya and Polytechnic of Jambi. This year, we had this flexible online conference to gather experts and scholars around the globe with the aim to continue disseminating the latest advanced research in the field of industrial automation, smart grid, economic, business and social humanities, and indeed to develop the academic exchange among researchers. The committee of ICIASGA and ICONEBS conference are honored to have invited following renowned experts or keynote speaker. Firstly, Professor Akhtar Kalam from Victoria University, Australia. Mr. Wahyu Kaisarendra, PhD from University Brunei Darussalam. Dr. Hazliza Ar-Rahim from University Malaysia Perlis. Associate Professor Dr. Melor M.D. Yunus from National University of Malaysia. Dr. Abu Yazid bin Abu Bakar from National University of Malaysia. And finally, Mr. Dani Ridwan, PhD from Ministry of Finance of the Republic of Indonesia. As the General Chair, I'm glad to share with you that around 160 pre-registered authors are submitted their work in the conference. However, it's about 85 papers are selected and accepted for the conference. All the papers have been through rigorous review and process to meet the requirements of international publication standard. As the General Chair of this conference committee, I have the honors to welcome you all the keynote speakers, all the presenters and participants to this conference, and I sincerely hope that you will enjoy the conference and gain some meaningful experience and knowledge. Again, thank you very much for your support and attention. Wassalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi wabarakatuh.
Thank you very much, Mr. Nur Asik, for the welcoming speech. Now, with honor, we invite Mr. Muhammad Fajar Sufan, STMT, as the Director of State Polytechnic of Madiun, to give the next welcoming speech. Mr. Fajar, time is yours.
Thank you. Assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi.
Good morning, everyone. dear ladies and gentlemen, invited speakers and colleges. I am pleased as the Director of State Polytechnic of Madiun to welcome you to the first international conference on industrial automation, smart grid and its application, or ICIASGA, and international conference on economic, business and social humanities, or ICONEBS 2020. The central theme of ICIASGA and ICONEBS is Green Technology and Energy 5.0, and the dynamic of economic, business, and social humanities, respectively. Alhamdulillah, let's thank God Almighty. Because of His blessing, we can gather here today to attend the conference. This year, we held the conference virtually due to COVID-19 pandemic. This conference is extremely important not only for the State Polytechnic of Madiun, but also for Indonesia vocational higher education. Moreover, the conference topics are closely and relevant to the current issue, which will be a good topic for researchers, scientists, and engineers to share their research finding, thought, knowledge, and ideas. I would like to express my gratitude to all keynote and invited speakers who are willing to share their professional expertise at this international conference. Allow me to take this opportunity to express my sincere appreciation to the authors, reviewers, advisory and organizing committee, as well as the chairperson. Without their hard work and contribution, this conference would have not been possible. Also, great appreciation to Aviation Polytechnic of Surabaya and Polytechnic of Jambi for co-hosting the conference. I do hope that you enjoy the conference and will have rewarding exchange knowledge through this conference. I wish you every success and looking forward to see you again in the next second ICIASGA and ICONEBS. Thank you very much. Wassalamualaikum warahmatullahi wabarakatuh.
Thank you, Mr. Fajar, for opening this conference. And now, to all of the audience, now we come to the end of this opening ceremony.
Yeah, I think that's all our sequence of opening ceremony. I will see you again in the different rooms in ICONEBS and ICSGA. See you from now. Goodbye. Thank you very much.
Yeah, let me put off my mask. We have already keep our distance in between moderator. And here, thank you for waiting for a while. Actually, we are waiting the keynote speakers to join in this room. And now, we are about to begin. In this session, we have 3 keynote speakers. Professor Akhtar Kalam, Associate Professor Dr. Hasliza, and also Mr. Wahyu Kasarendra. However, here it seems that we have already Mr. Wahyu already joined in this room, so that we can begin our ICIASGA 2020 sessions. Excellencies, participants, ladies and gentlemen, good morning. And we are delighted to welcome you to the first ICIASGA 2020 International Conference on Industrial Automation, Smart Grid, and its applications, State Polytechnic of Madiun. I am Alif, in charge as the moderator for the first and second keynote speakers. Before starting the session, I would like to remind you a couple of rules for the sessions. The first, please make sure to switch on your video and switch off or mute the microphone. Second one, In this session, we have for about 1 hour for 3 keynote speakers to deliver their presentation, and every keynote speaker will have for about 20 minutes to present presentation. Later on, we will give you a question and answer session after the presentation over. Yeah. And to the keynote speaker, excuse me that let us remind you whenever the time for the presentation is merely left for 5 minutes. Oh yeah, I see. Thank you. Please, for the participants in these rooms in ICSGA, this room is for ICSGA participants. However, if you are for participant for ICONEBS, would you please move to the different chamber? I think the links already given by committee in the live chat. Okay. Okay. Anyway, I think first I would like to welcome the first keynote speaker to deliver the presentation, and here we have already have Mr. Wahyu Kasarendra, PhD. Let me read in brief his curriculum vitae before Mr. Wahyu deliver the presentation. Mr. Wahyu has born in Jakarta, Indonesia, January 31st, 1982. He received Bachelor of Engineering degree from Diponegoro University, Indonesia, 2005. He worked in automotive and electrical company prior to join Diponegoro University as lecturer in 2000 and 2007. He received New University for Regional Innovation and Brain Korea 2021 scholarship for master study in 2008. Obtained his Master of Engineering degree from Pukyong National University, South Korea, 2010. In 2011, Mr. Wahyu awarded of University Postgraduate Award and International Postgraduate Tuition Award from University of Wollongong. He received Doctor of Philosophy PhD degree from University of Wollongong in 2015. He published more than 25 research articles in journals and conference proceedings. One of them was being the top 25 most cited paper in Mechanical System and Signal Processing Journal. He was developed skills and experience in scholarly research, teaching, learning activities. He is currently postdoctoral fellow in Rolls-Royce NTU Corps Lab School of Mechanical and Aerospace Engineering, Nanyang Technological University, Singapore. Ladies and gentlemen, we would proudly present Mr. Wahyu Kasarendra, PhD. To Mr. Wahyu, time is yours. Thank you.
I would like to thank the ICIASGA committee for inviting me in this conference. I was expected to come directly to you because I think last I was invited to this conference, and suddenly COVID-19 is happened in recently, so I don't have to go to Madiun. Okay, thank you for also for the moderator introducing my. But I think the is not up yet because I am currently is okay. I think I will share my screen now. Okay. Just in line with the conference theme, conference topic is about the green technology and industry 5.0. I would like to present some of the green technology projects that I have currently ongoing and also maybe one potential project in the future. Yeah, let me introduce myself again, because I think the one that read by the moderator is not up to date. This is not update yet, because I'm currently an assistant professor in Faculty of Integrated Technologies, University Brunei Darussalam. I'm graduating. I graduated from Diponegoro University and Pukyong for bachelor and master of engineering, and I obtained my PhD degree from University of Wollongong, Australia. And after that, I continue to 2 years for postdoc in School of Mechanical and Aerospace Engineering, Nanyang Technological University, Singapore. Okay, this is my research interest. If someone or maybe anyone would like to collaborate with me, I have experience in product design, mechatronics and robotics, smart manufacturing, and also machine learning. Some of them already patented in Indonesia, HKI. Also, I also have just recently, very viral in the 2030 that I designed the valve for the mass. This is the content of the presentation today. I would like to introduce about the Industry 5.0, because it's also new for me. And I would like to show my result as a postdoc fellow last time in Singapore, NTU, about Industry 4.0. And next will be green technology and energy 5.0 projects that I have been doing at the moment. And I will also present one potential or future projects towards Industry 5.0. Maybe the lecturer from Polytechnic Negeri Madiun can collaborate, and also PT Inka also can collaborate in this project and conclusion. Maybe this is the overview of the evolution of industry. I will not go into detail about what is the first industrial revolution, second, third, and so on. But I would like to just highlight in the last industrial evolution, which is Industrial 5.0 and 4.0. According to Michael Rada, is quite common in the internet. Sorry, Industrial 5.0. What's the difference between the Industry 4.0 is comparing with Industry 4.0, which is being considered as next industrial revolution, but it's more a systematic transformation that includes impact on civil society. This is the clue. The difference between the Industry 5.0 and 4.0 is that the Industry 5.0 include the impact of civil society, governance structure, and human identity. This is the the comparison, because also that's realized that the Industry 5.0 just started this year, maybe 2020. Before 2020 is we call like Industry 4.0, but starting of this maybe 2020, it will be moved to the Industry 5.0. I will give the example of the 4.0 project in NTU in the next slide. The Industry 4.0 is the introduction of the connected devices and data analytics and AI. So if your manufacturing system or maybe an industrial system has been applied the AI or data analytics or IoT, we can call that our system or manufacturing system is already, or industrial system is already applied Industry 4.0 scheme or the platform. Okay, so and then the Industry 5.0 we call the future, but I think already started in 2020 this year. The fifth industrial revolution, Industry 5.0, will be focused on the cooperation between man and machine. This will be highlighted. So man and machine, or human and machine, will be collaborate as human intelligence work in harmony with cognitive computing. By putting humans back into industrial production with collaborative robots, workers will be upskilled to provide value-added tasks in production, leading to mass customization and personalization for customer. So the difference between the 4.0 and 5.0 is we also include human involvement in 5.0. We will see what okay, before we go to the project that I've conducted at the moment, I will just review my project during 2 years in Nanyang Technological University, Singapore, about Industry 4.0. I developed the machine learning. If you remember that one of the highlight of the Industry 4.0 is you applied AI, artificial intelligence, including machine learning or deep learning into the industrial system. In this case, I applied machine learning into the manufacturing in Rolls-Royce aircraft industry. So the part that I the object of my research last time is the number 1 and number 2 is the combustor casing, and also number 1 is combustor casing in the engine, aircraft engine. Sorry, and the second is a fan blade. So this is the one that manufactured in the Rolls-Royce Singapore. Okay, the previous method before we introduce the machine learning, the polishing or the abrasive processes is done as shown in this, as presented in these figures. We remove the materials. We call polishing or abrasive. Once we remove the material, the surface, and then we will measure the thickness of the materials. So you can imagine that after you do polishing or abrasive, anytime you need to measure the thickness of the materials by manual. So this will be time consuming as well as need some effort, and also need some human activity or involvement. So we would like to remove this time consuming work by introducing the machine learning into the polishing process in Rolls-Royce industry. So I use vibration sensor. I use vibration sensor that attached on the aligned head of the abrasive tools or polishing tools. So this sensor will be recorded the signals, and at the same time we need to have like a label first. So after we record the signal, we also label it with the thickness as well. So both data, raw data like vibration data and the thickness data, will be fit into the machine learning model, and then finally will be and next time will be after we get the model. So we can also test the model with the new signal without labeling, and finally the online or in process measurement is developed. I will show the video later on. This is a video. You can see about 2 minutes maybe. This is the fan blade it's used for the aircraft engine. There is the ABB robot that doing the polishing. You can see once the tool starts to the metal or surface, it will be showing the vibration signal. So this vibration signal will be input the machine learning, and then you can see from this block, this is the thickness measurement of particular point. So you can see there is automatically it's showing the like a 1.2 millimeter thickness, and maybe 8.2. Yeah, you can see from here these numbers indicate the thickness of the fan blade under processing. So you can imagine that the manual process already removed from the manufacturing line, and you can see very very effective to do the process. After this, we will see the result of accuracy comparison between the actual thickness and the predicted thickness. You can see how accurate the machine learning is. Yeah, it takes very long because from top left top, and then it's going slowly into the wall surface of the fan blade. You can see from the right top, there are the numbers that are showing the predicted actual. So you can imagine that the machine learning can predict very well according to this result. only 2.45 for the predicted and 2.48 for the actual. So it's very accurate, about above 95%. So okay, I will just quickly. So this is the application of one example of application of Industry 4.0 in industrial and manufacturing. Yeah, okay. Videos. Thank you for watching. I will continue the slide. So next topic about the green technology and energy 5.0 projects that I have supervised. I have two PhD students at the moment in University Brunei Darussalam. One is about the semi-autonomous robot for solution to water pollution from floating trash. And the second one is the Internet of Things, IoT system to improve building energy efficiency. We will have a look the number one project. So if you imagine that if you read in the maybe many literature or newspaper or online news that currently the floating rubbish, floating trash is increased every year in our ocean, maybe also river, anything, then will be dangerous. So some of the researchers in robotics already developed some of the example of their water floating robots or trash to collect the trash. And this is an example of the robots, CFAX and waste shark. And also we would like to actually adapt this idea into the maybe Brunei and Indonesia. We develop this kind of the robot that include the controller box, water wheels, motor, storage. This is the sort of the rubbish, equator, and then conveyor as well. So this design is made by my PhD student, and this is the schematic of the autonomous robot as a solution to water pollution. So there are a lot of sensors here. So this is, I think this belong to Industry 5.0 because it will be like collaboration between human and robot, because human also involved in this activity. So there are a lot of sensors here. So I will explain maybe later on because it's still ongoing. There are maybe about 4 sensors that located on the edge of the robot to detect the position. And there is a conveyor belt to collect the floating rubbish or floating waste from the surface, and there is an electrical compartment here. So next time we will also connect to the GPS to know the location of the robot in the river. So this is the testing, the first testing of the robot in the lake, in one of the lake in Brunei. So this is I think I will just show the video showing that the robot can collect the water bottle in the river, in the lake Brunei. So currently still meanwhile we just direct the robot into the rubbish, but next time we will apply like a machine learning or deep learning to find the location of the rubbish, and then they will collect it by automatically.
Excuse
this
me,
robot is
Wahyu?
also already successful, but I also have another project, similar project in Indonesia that collaborated with the this is robot is already developed in Brunei with my student, and we have another project, similar project in Indonesia as well. So I will explain after this.
Excuse
So
me,
we call like a
Wahyu?
seawater robo.
I would like Thank you.
So I have another project with the Universitas Sudirman, Purwokerto. Alhamdulillah, one patent application has been submitted for this project. We call like a seawater robo, and this is the name of the title of the patent, submitted patent, robot pengambil sampah terapung tipe quad propeller. So I will explain a little bit. Okay, this is also some of the introduction of the rabies in Indonesia. You can see from kompas.com and some of the online newspaper that a number of floating waste in Indonesia is increased every year. And then we would like to develop one robot that is designed to solve this issue. We call the seawater robot. Okay, as you can see from here. So see, this is this first prototype made by my college in. I would design from here. I was the designer of this, and then I also take part in the mechatronics area or the controller, everything. But it was what this is manufactured in Indonesia. Everything like we have in this robot there are 4 propellers. You can see from the picture that this one propeller, 1, 2 on the backs, and 2 at the side of the robot. So this propeller is, you can see, different with the previous one I designed in Brunei. Why? Because in Brunei, the river and maybe the river and what lake is quite not too. I mean, there is no underwater plants. It's like just water. But Indonesia has a different different environment. So usually in Indonesia, like a lake and river, there are a lot of underwater plant that can make the propeller wheels. If you design something like this, the wheels will be trapped into the underwater plant or vegetation. Yeah. So I have, and then I modified my design. And then I think that both propeller will be better in Indonesia because Indonesia has a different typical type of the water. So I have designed 4 propellers with the 4 BLDC, brushless DC motor, to make the movement of the robot. And the process of the 4 propeller are located above the robot because buoyancy tube above the buoyancy tube to prevent jam from underwater plant that commonly exists in Indonesia. This is the reason why we put the 4 propeller above the buoyancy tube. So the robot is also equipped with one conveyor to collect the floating waste and put it in the middle box. So the front view. This is the front view. This is the back view. There is a conveyor. This will be like on if there is some rest on the in front of the robot. So we will be bring the rest into the rubbish box. This is already tested, but not perfect yet. Still ongoing. And still now, we still use like a remote control first, so with transmission to control 4 BDC motor and propellers and 1 servo motor for conveyor. And next time we will use the camera to and embedded AI to look at the floating waste. Okay, and then so the next is about the IoT system for building energy efficiency. You can see from this building. Let's go. Sorry, this from this image that the temperature is higher every year. So in Brunei, we would like also develop we call like one building with the green system. You can also see from this picture that Indonesia is the highest energy consumption, and most of energy consumption is from the buildings. So building is the major energy consumption in the world. So we would like to reduce, and then if you break down the building, it has some components which is like with aircon, lighting, space heating, everything. So I think the highest one will be aircon, So we would like to develop
Yes.
one building with the auto system to compare between the building without the graded system and the building with inner system. So this is the one that we will conduct it in the future. We already purchased all the sensors. There's we will put the weather sensor, heat flux sensor, room temperature and humidity sensor, surface temperature and lift area index. We will put inside, and then the left building will be a normal building, and then the right building will be equipped and add like a greenery system. We will compare later on. And the building still ongoing, still under construction. Hopefully next year will be established and we will put sensor. And another project that will be potential for the INCA and also the PN Polytechnic of Madiun is like a right index analysis. I need one student from Indonesia to conduct this research. So this is about if you see like a Ministry of Transportation Indonesia, the regulation, one of the important things is vibration. So in the rail, you need to measure about the vibration. So in this case, I would like to develop like a rad index analysis, because the one that has been buy or used in Indonesia is very expensive. But this is actually is not difficult to develop our own. I would like to start this project maybe in the future if I have one PhD student. Okay, now conclusion in my PPT, because all of my projects still ongoing. And if you would like to collaborate with me, you can contact in my email. Thank you very much.
Thank you very much, Mr. Wahyu. Sorry for limited time for the presentation. Very interesting presentation, especially for the trash collecting robots. Yeah, very useful, and I think we need Indonesia such kind of robot audiences in these chambers, in this room. If you have questions related with the presentation for Mr. Wahyu or Pak Wahyu, you may keep or you may type your question in the live chat, or you may deliver directly later after the third presenter finish or present their presentations. And now we will move to the second keynote speaker to deliver his presentation. Here we have already also joined in this room Mr. Professor Akhtar Kalam. Let me introduce in brief Mr. Professor Akhtar Kalam. He is a professor of electrical engineering in the College of Engineering and Science at Victoria University, Melbourne, Australia. He has been Deputy Dean of the Faculty of Health, Engineering and Science at Victoria University for 7 years since 1999. He has wide experiences in educational institution and industry across 4 continents. He has conducted research, provided consultancy, and has over 308 publications, primarily on power system protection and independent power generation. Ladies and gentlemen, please welcome Prof. Akhtar Kalam from Victoria University. Prof. Akhtar Kalam, time is yours, please.
Thank you very much. Assalamu alaikum. Can you hear me? Can all of you hear me? Can you hear me, please?
Yeah, we can hear your voice clearly. Yeah.
Can you see my slides, please? Is everything okay?
Yeah, we can.
Okay, good.
Yeah,
Thank you very much.
Thank you very much.
Thank you. My presentation, and before I start the presentation, I would like to thank the General Chair, Nur Aishik Hidayatullah, for inviting me. I was looking forward to come to Indonesia. I've never been to Indonesia, and I was wondering this would have been my first time, but inshallah next time. I love to visit Indonesia. Nur Aishik was my student long time back, and it's good to see Nur Aishik so much useful in Indonesia. Now, my presentation is on smart grid, the opportunities and challenges. So, without further ado, just wanted to mention that in today's presentation, I'll be giving you the introduction. What is smart grid? What are the opportunities and challenges? And if we have some chance of question and answer. Now, if we look at the energy business itself, this is a huge business, my friends. I mean, we're talking about $1.3 trillion business. We're not talking about small business. We're talking about huge business. We're talking about energy purchases, energy operation, energy financing. The purchase could be procurement, distribution, metering and billing. The operation could be infrastructure, space conditioning, process monitoring, process system monitoring, and finance and investment or administration. Now look at this very carefully. Engineers are only 1/3. The rest of them are business people or government. So a lot of things in energy area will come from the government incentives. Now, I'd like to start with something very, very provocative. Do you think that the industry that we have today is going to be the same in 20 years' time, or will it be different? Let us see what is the industry going to be like. This is my traditional grid from transmission all the way up to the domestic end where my consumer buildings are, right? As Professor Cassandra was mentioning, the so-called smart building, the net zero building, those are the types of building we'll be having with a lot of smart features, with a lot of sensors, with a lot of comms. All those things will be there in that building. But the backbone is still the same. There is high voltage generation using transformers. Then you've got high voltage transmission line. You've got all these distribution feeders, the sub-transmission systems, and then back to our humble home. But look at the difference that is going to come later on. And these differences are the ones which is going to make the changes. You're going to now have wind farm. You're going to have PV panels on the top of your roof. You're going to have electric cars. You're going to have comms. Look at all the communications that will come in. You will be having AMI, that is artificial, the applied metering infrastructure, the advanced metering infrastructure will be there. So a lot of smart meters will come in. A lot of underground distribution system, which was not there. You will be using XLPE. You might be using superconductors. You might be using all sorts of things that is going to be there. Then there could be radio control receivers with a lot of smart antennas. The power flow will still be there, but along with that, there will be a new layer coming in, which will be the comms layer. So this is my smart grid. Okay, these are my city's offices. This is the smart house. There's the Professor Cassandra was mentioning a few minutes back, right? These will be the smart cities and offices. A lot of new factories. You may have nuclear power plant, thermal power plant, hydraulic power generation, solar generation, wind generation, electric vehicle, new transmission station, new distribution station, all these new type of conductors that will be coming in. So the whole grid will be completely different. Now, it won't be only smart buildings. It won't be only smart buildings like Professor Cassandra was mentioning about smart building. This is a very small part of the equation. The smart buildings will naturally will have intelligent systems with a lot of smart devices, with grid integration, etc. But then the whole city will be smart, which will be very complex, which will have interconnected infrastructure and services. Then the grid itself, no more there will be monoflow, it will be bidirectional. Okay, remote control and automation will be there. A lot of DERs will come, distributed energy resources. Then the smart energy itself will be not only electric power, it could be gas, it could be smart water, everything combined together. So this is what, from humble smart building, we'll be going to a whole smart energy sector. Now, someone asked me a question, what is smart grid? What do you understand by smart grid? The difference is exactly similar to a normal phone and a smartphone. This is what the difference. This is my traditional grid that we have today, and this is the grid that we are going to have tomorrow. This is the conventional one, and this is the smart one. This is exactly the same. So now, the 10 countries in the world which are giving a lot of investment, naturally the top one is China. The top one is China, followed by US. But don't forget, Australia is here. Australia is number 7. So we are in the top 10 countries in the world where a lot of federal smart grid investments are there. But now, naturally, $360 million compared to $7.32 billion is a drop in an ocean. But we are in the race. That's all I wanted to say. And I wanted to mention to you, we are second only to Germany, better than UK and France and Brazil. Now, what is the motivation that we want to go for smart grid? I want to make my grid smarter. I want to make my grid safer. I want to make my grid reliable. I want my grid to be very cost effective. That is why I'm going to use sensors, COM technologies, and distributed computing. Therefore, if I start with my generation all the way up to my humble freight, all that portion should all be smart. So, what is a smart grid? Is it a thing? Is it a vision? I believe it's an evolution. It's a journey. It's a journey where the values are such that it is reliable, very economic, very efficient, very secure, very environmentally friendly, and very safe. What are the characteristics of this? Consumers will become active participants. Therefore, I want to introduce a new term called prosumer. You're no longer consuming electricity, you're also producing electricity and selling electricity. So that term consumers will become a prosumer. All sorts of generation and storage options will come in. It won't be just conventional thermal generation or hydro generation. You will have wind, you will have solar, you will have ocean thermal, you will have biomass. I don't know, all that waste that Professor Cassandra is collecting, why can't we use all that and produce energy? We want to have power quality in the digital world that we live in today. We want to utilize our asset and operate it very efficiently. We want to respond to any disturbances. We want to respond to any disturbances that we have. We want to respond to any disturbances we want to have as quickly as possible. Therefore, you will have concept of self-healing, where a fault occurred. When the fault occurred, it took me few minutes to repair the fault. Now it'll be done in few seconds. This is a very dangerous thing. Cyber attack. Our system has to be secure or resilient against any attack, against any natural disaster. We cannot have things like tsunami, cyclone, or an 18-year-old kid coming in and spoiling our grid completely. The milestones will be consumers will be enablers. You'll have a huge amount of advanced distribution operation. There will be new advanced transmission operation, and there will be advanced asset management. So my observation is that there is really no defining features. I mean, I can't find any defining features. If I were to give you a silver bullet, there is no such silver bullet. Everyone says that we have got smart grid, and everyone says that this is not complete. But the most important thing is that it is basically change in your mindset. This is a new technology. You have to understand this. You have to change it in your mind. You have got now competition from those who are not traditional grid suppliers. You've got telcos like Telstras, Optus, all these telecommunication companies. They are your competitors nowadays. You've never heard of your IT, the hardware and the software people. Google, the IBMs, they are your network providers. And a lot of things like Cisco, etc., will be giving you the specialist solutions. In Australia, we've got many aspects of the grid which is smart, but much of them is in the high voltage area, not much on the low voltage area. So look at this traditional grid. This is our traditional grid. We used to get power in our buildings and all from traditional grid. Some people use it offshore plants also to get gas, etc. We get it from the Bass Strait also, and we get power from there. But many people have got onshore plant, and they are supplying the consumers directly from there. This is our traditional way of supplying electricity. Now what we have done, we have integrated wind over here. Look at the wind generation, either onshore or offshore. All our houses, we have got PV panels on the top of the houses. So we have integrated renewables with the traditional grid. Now look at the smart grid. Okay, if you look at the smart grid, I've got all these wind generation, I've got solar generation, I've got electric cars, I've got a lot of things that has come in, and that has made the grid smart. No longer the direction of flow is in one direction. The direction is everywhere. Everyone is talking to each other. Now, what is the smart grid? We will have new type of storage. We will be using plug-in vehicle. The vehicle itself will be a storage capacity. We will be using new type of charging and billing. The grid capacity will increase. You'll be using new type of load management, and we'll be going for real-time pricing. I think that off-peak period and the on-peak period that we traditionally have had for a long time may disappear. Now, look at this. This is before we had smart grid. Look at the flow of power. This is how the power used to flow to our humble houses. Now, look at all the directions that the power is flowing. And look at all these new people, the PVs, the smart houses, the smart vehicle. You've got all sorts of things that has come in, and therefore there are multi-stakeholder, and there has to be interaction between one and the other. So my question is that, is everything now going to be smart? I believe that this has been very well answered in the Harvard Business Review, where it was said that smart connected products are changing, how value is created, how companies compete, what are the boundaries of competition itself. These shifts will affect everyone. It will affect every industry, directly and indirectly. Remember, electricity is a connected product. Smartness is basically non-commodity. Now look at that. Consumers are no longer consumers. They're no longer a customer. They are prosumers. They are also producing electricity. Competition is changing the electricity sector, and the electricity is being heavily impacted. So a bit on the prosumers. There's going to be mass customization. That means there'll be mass production of customized products. We will bring customers into the value chain by involving the customers in production. So the customers are also going to be producers. So there's going to be value sharing and the prosumer oriented. So therefore now the customer who is the prosumer is an active energy market participant. The prosumer is economically motivated. The prosumer is a co-player. A prosumer has enough market power, and that could be quite significant. So let us look at this. Will the electricity market look radically different in the future? No doubt about it, there's going to be volatility of electricity market. Therefore, if there is going to be volatility of the market, this will require that we have a flexible response of the system. Look at how the average prices in Denmark and Norway changes between summer and winter. And look at how the differences in the two states, which are two countries which are close proximately, but still there is substantial pricing differences depending on the volatility of the electricity. But this may not happen too, because this might create a worse scenario for the business if the infrastructure volatility is big. Now, let us see if there is value creation for smart grid for all stakeholders. That means the utilities, the regulators, the customers, the vendors. If there is a new value chain, is going to change. But it might not happen because it is highly dependent on local specifics and regulatory environment. If the regulatory environment and the local specifics are not conducive, this might not happen. The third case is when we are going to have innovative products. Look at the type of plugs we are going to have, not longer traditional. This will have multiple impact on the power systems. However, there is a lot of partnership involved. And when there is more partnership involved, more integrated solutions are required. This may not happen. The fourth example is that it's going to be huge amount of attractive business. No longer we will have a car which will be driven by IC engine. The car will also be a source of power. And it might not happen because if there is not enough clout and speed to keep the chain. Professor Cassandra was talking about smart homes and Internet of Things. If we do not have enough clout and service in the cloud, all the things that he was talking about may not happen. Now, the last portion that I wanted to mention was there's going to be disruptive technologies, and that is electric vehicles, which is going to attract talent, capital, and attention. But it might not happen if this is not economically viable. So you will find it all depends on the local market, it all depends on the distribution system operator, and it all depends on the rural grid component. So the whole thing is interdependent on one another. Now look at the merging power flow with information technology. That's what I was trying to tell you. A new structure will come. This is the new structure. This is the structure I know. This is my power structure. I know I've got my generation, I've got my transmission, I've got my distribution. We have put in smart meters. This is my premises, whether it's home area network, building area network, industrial area network. Professor Cassandra was talking about the building area network, right? This is my traditional power system. Now we have a new layer, the comms layer, where all the LAN will be there, the WAN will be there, the NAN will be there, the FAN will be there, all the AMIs will be there. Again, the home area network, the building area network, and the industrial area network. So a lot of comms will start in. Look at all the amount of antennas, the sensors, all the Industry 4. Industry 4 is outdated. It'll be Industry 5, which will come in. So, the first thing we have to do, make sure that our consumers, the prosumers, the customers, they're aware of such change. So a lot of education is required. Maybe this is a good chance for a State Polytechnic of Madiun to be taking a lead in this and teaching smart grid rather than teaching conventional power systems. A lot of rules and regulations will change. Huge things on cyber security and privacy will be coming in. Standards need to be changed. Technology is small. I told you, technology is not important. It is the mindset. If that is clear, if we have got the education right, all that will be taken care of. So, what are the attributes? The attributes will be that you will have an intelligent transmission and distribution system where there will be a lot of microgrids, a lot of islanding, a lot of switching, a lot of sectionalizing. There'll be distributed generation, what I call DERs, which will have PVs, the wind, the micro turbine, the compressed air energy system, the flywheel. You're hearing about lithium ion batteries. They might go away. Sodium batteries will come in. We will have new infrastructure, the AMI, which will have the broadband power line, the radio frequency mesh, the power line carriers, the radio frequency tower, where there will be a lot of readings to be done, remote disconnection to be done, the capacity control to be there, sensors to be there, and wastewater utilization will be there. That is where the gray water will come in. Now, at the building itself, the smart building, the net zero building that I was talking to you about, in there, we will be having, in the premises itself, we will be having oh gosh. We will be having in this, just a minute, please. Okay. In the building itself, we will be having this a building where there will be in-premise network, the automated distribution resources, integrated demand-side resources. Your fridge itself, your humble fridge, will be very, very smart. So the characterization of smart grid will be that we'll be using more and more digital information and control technologies. We will have dynamic optimization of grid operation. We will be utilizing cyber security to the full. We'll be deploying and grid integration of all DERs. We will be operating the demand response and energy efficiency program. This is where I was more concerned about. There's a lot of problems when Professor Cassandra was talking about. He was talking about energy conservation. It is not energy conservation which is important. Energy efficiency. You do not want your customer to lose the service that they have been used to till now. You want them to get the same services but with a better efficiency. We want to utilize smart technologies for metering, comms, looking at the grid operation. We want to integrate the consumer devices and technologies. We want to deploy electric vehicles and storage. That is, look at the thermal storage, mechanical storage, and the electrical storage. So the interconnected network, look at the interconnected network. We will have intelligent load, right? We will have distribution network. We will have all sorts of wind generation. We will have smart inverters and storage. We will have control room functions. We will have distributed architecture, lot of microgrids, lot of bulk power plant, and huge amount of sensors which will be detecting outages, fluctuations, and any disturbances in the system. So I want a grid which is very, very strong, or do I want a grid which is secure, resilient, and adaptable. Resilient against any attack and adaptable. So let us see what sort of control you have got. And we have to look both in the components level as well as system level. Various nonlinear controls are applied to control the distributed energy resources and the grid integration. These are backstepping control, feedback linearization, model predictive control, and sliding mode control. So we will be relying on smart grid communication because we want to have speedy communication facilities, and that will become the integral part of the functioning of the smart grid. The feature will incorporate a lot of fibers coming into the system. You will be having microwaves. You will be having global system for mobile communication. You'll be having general packet radio services. You'll be having 3Gs, 4Gs. Now we are talking about 5Gs. And there will be integration of artificial intelligence in this smart grid application. That's what Professor Cassandra was talking about, machine learning, etc. That'll come in. So, what will be my smart grid look like? My smart grid, smart, S-M-A-R-T. My S stands for signal processing, state estimation, stochastic generation, self-healing. My M stands for monitoring. I'll be using VAMs. I'll be using multi-energy carriers. I'll be using multivariable optimization or control. I'll be having mixed type of generation. No more just thermal, no more just hydro. All sorts of generation I'll have. And it'll be a market enabler. That is M. A is for adaptive. You won't create new thing. The grid will still be there. It has to adapt to, and with a new hierarchical control, there must be augmented power transfer. You'll be using lot of flexible AC transmission system, and HVDC will be used for interconnection. And therefore, one of the things which is most important is that it must be affordable. That is A. My R stands for robust. It must be responsive to demand. You must have reliable ICT. You will be using a lot of renewable energy resources. You will be having real-time control, and you will be using reduced uncertainty. And the T stands for transcontinental, tailored for individuals, tolerant to behavior patterns, and the trade-off analysis. This grid has to become smarter than what I have told you. So this is the smart grid, and it has to become smarter. So in conclusion, I believe that digital revolution is changing the value chain. I also believe we have got consumers now. They are no longer going to be consumers. They are prosumers, my friend. The prosumers will gain market force. There is a target of decarbonization of electricity system. You know that. Professor Cassandra did mention about residential home being consuming electricity a lot. I believe transportation consume more energy than residential home. They are going to become a huge factor. We have to do decarbonization. We have to look at the distributed system operator will be the core of digitalization, decarbonization, and decentralization strategy. We will be using, as I mentioned, flexible AC transmission system, HVDC system. We will be using a lot of electric storage. We will be having a lot of charging infrastructure. In Australia, we have connected Melbourne to Sydney. We have got 18 charging stations in that 850 kilometers. You can easily drive from Melbourne to Sydney in 7 hours, in 8 hours, which is 850 kilometers, using an electric vehicle. We've got enough electric infrastructure. In about 5 years' time, most of our roads in Australia will have enough charging station to have your electric vehicle drive safely through the whole country. We have to have industry standards. That needs to be promoted. And the best thing is that for institution like State Polytechnic of Madiun, believe me, your young engineers, young engineers who will be so good if they have got this knowledge of smart system, they will be the one who will be attracted to the power industry and their future will be secure. So, in fact, Abraham Lincoln said, the best thing about the future is that it comes only one day at a time. I'm glad it only comes one day at a time rather than the whole thing at one time. We are learning a lot of new lessons in this COVID situation. And I'm glad only one thing is coming. And I'm telling you right now, smart grid is going to be the future. Smart grid is going to give your student job. Smart grid is going to make your young engineers much more smarter, adaptable, and will be able to run your electricity system to the best capability with the highest efficiency and with the resilience that they deserve. Thank you very much. Thanks a lot.
Thank you. Thank you. Thank you very much to the Professor Akhtar Kalam. Very great and strong presentation, as well as motivating for young especially. Thank you very much, Professor.
Voice, all the audiences. Yes, great. So now we move to the last keynote speaker. So we would like to invite Associate Professor Dr. Hasliza Arahim from University Malaysia Perlis. Good morning, Mrs. Hasliza. And first of all, let me introduce Associate Professor Dr. Hasliza Arahim in a brief. She is an associate professor at School of Computer and Communication Engineering at UNIMAP. She completed her PhD in Communication Engineering from UNIMAP in 2015. She is actively engaged with Bioelectromagnetic Research Group, BioEM, School of Computer and Communication Engineering. Her skill and expertise including antennas and propagations, wireless communication, radio propagation, electromagnetics, microwave engineering, and then electrical engineering, antenna design, and telecommunication engineering. Okay, ladies and gentlemen, please welcome Associate Professor Dr. Hasliza Arahim. You have for about 20 minutes to present your topic. Time is yours. Thank you.
Okay, so today I would like to present my keynote speech. Which is quite different than the previous keynote speakers. And I believe that these topics are very close to the usage of waste material, which are abundant in Malaysia and also Indonesia. So this topic is actually centralized around the theme of this conference, ICIASGA, and I also believe it will bring benefits to all participants, especially for the Polytechnic Negeri Madiun, Indonesia. Okay, so the title of my topic for today is Green Coconut Coir Fiber Nanocellulose Composites as Electromagnetic Absorbers and Flexible Wearable Antennas, Potential Current Developments and Future Perspectives. Okay, so what I'm going to focus for today is on the current developments in the area of electromagnetic absorbers and also flexible wearable antennas. Okay, so before we go deep into our main focus for today, I would like to briefly explain about the electromagnetic absorptions. Is any participants do this kind of research current research? No? Okay, but okay, so let me explain. So what is actually electromagnetic absorptions, and the advantage of electromagnetic absorptions, and how we can utilize this electromagnetic absorption. Okay, so first of all, electromagnetic, we call that as a EM absorption, is the ability of the materials to attenuate or absorb the EM radiation inside materials. Okay, so as we all realize today, we have so many radiation around us because we are using Wi-Fi, access points, the base stations, just 1 kilometer from our house. Okay, so we are actually exposing ourselves to this electromagnetic radiation without we realize whether it is dangerous to our health or not. Okay, that is why the design of the electromagnetic absorption becomes useful, and that is one thing. And another thing is this EM absorption capability is widely being used in radar communication. Why? Because in radar communication devices, especially the satellite and so on, this system must have the capability to absorb the unnecessary electromagnetic that is surrounding the system of the radar. Okay, so electromagnetic absorption is being determined by two key parameters, by two important parameters. It relies on this parameter. The first one is permittivity, and the second one is permeability. Permittivity means that the properties where it acts like an insulator. When you transmit any electromagnetic, it has the capability of the EM absorber depends on this permittivity. The higher the permittivity of the material is, it means that it has higher capability of absorbing. Similarly to the permeability. Okay, permeability depends on the conductivity. Okay, whereas for the permeability, it depends on the magnetic properties. Okay, so these are the schematic of how does the mechanism of the electromagnetic absorption happens in the absorption materials. Okay, so if you have any incident field, whether it is a normal incidence or oblique incidence, it will go through the absorption material, and some of the signal will be reflected, some of the signal will be transmitted and have a multiple reflection. So the good EM absorption material means that it will reduce the reflected field. So it has a capability to absorb as much as possible, and 100 absorption, we call that as a perfect absorber. Okay, so these are the schematic of how does the EM absorption happens. So if you have an absorber and you have a metal, so metal actually acts as a reflector, so that any transmitted signal from outsiders go through the absorber will be reflected back to the absorber if you have metal. And on my right hand side is for the multi-layer. So if you compare between single and multi-layer, of course, multi-layer will have better absorption rate because we have many layers of the absorber, where it will increase the capability of that kind of absorber to absorb more electromagnetic signals. Okay, So now, I would like to explain about the revolutionized microwave absorber, and we know that microwave absorber are being widely used for the antenna or microwave devices testing, and also it has been widely used for the electromagnetic packaging, and also for the radar communication. Okay. So the first type of revolutionized microwave absorber is the nano-composite absorbing material, and people have been concentrated on the nanomaterial to increase the capability of the absorbing materials. And the second one is the meta-material absorbers, and this is actually the hot topic for today, meta-material absorbers, because it is kind of new, and then so many peoples are focusing on the metamaterials, and I will explain the advantage of the metamaterial absorber. The third one is the green microwave absorber. Okay, so the researchers around the world today are working out to design and also to produce microwave absorber, because the commercial microwave absorber nowadays are made from the synthetic chemical. It is bulky and also expensive. It is not cheap. So if you want to build the anechoic chamber equipped with a microwave absorber, you need to spend around 100,000 ringgit. And I believe it's around millions in rupiah. Okay, so it costs a lot of monies. Okay, and the third one is the revolution of the green microwave absorber, and this is also a new and a future research for the microwave absorber and also flexible antenna. This is what we call as a nanocellulose. So I will explain later on what is nanocellulose that can be derived from the agriculture waste, such as the rice straw, the rice husk, sugarcane bagasse. So the farmers in Malaysia or in Indonesia no need to burn all of this abundant waste anymore. They can turn this waste into wealth. They can even sell out to the industry who are going to produce this type of green products. Okay, so nano-composite absorbing materials. So what is it actually? Okay, so as we know that the nano-composite is made of nanomaterials. And why researchers and people are interested in this nanocomposite? First one, it is lightweight, thin thickness, very thin, high absorption capability, and wide operating frequency band. So it means that it can absorb the frequency bands ranging from 2 gigahertz up until 18 gigahertz. And the advantage of this is it is thin and also lightweight compared to the commercial microwave absorber made from the synthetic chemical materials. Okay, because that one is bulky. And in fact, in Europe also, they produce this kind of thin absorbing material, but it is also expensive. Okay, so that material is the flat one is what we call as a EcoSoft. Okay, and this depend on the geometry, particle distribution, morphology, and the type of filler. And this is the example of the nano-composite absorbing materials. Okay, so actually we are not composing the materials from the nano materials. We are actually using the nano composites such as graphene, carbon nanotubes, act as a a reinforced material, or we call that as a filler. Okay, so as we can see here, this is a TEM image, the microstructure image of the nanocomposite that gives in nanometer. Okay, the structure of the absorbing materials and reinforced by the nanocomposite, as we can see, is in nano size. And as we can see here, okay, as we can see here, is it? Okay, on my right hand side is the TEM images for the silver. Actually, AG stands for silver. Silver combination with the carbon nanotube nanoparticles that made these absorbing materials have a better absorption rates. Okay, so this is the current development of the absorbing materials for the absorber, microwave absorber, and also for the flexible antenna. Okay, and we go for the second revolutionized absorbing material. This is what we call as a meta material and meta surface based absorber. So what is actually meta material? Okay, and people are wondering about this. Meta material does not exist in this world. Okay, this is actually the engineered version of the material. So we made it we manipulate the material based on their characteristic and how we define the metamaterial. So metamaterial depends on the parameter, two parameter that I highlighted before, permittivity and also permittivity. So in order the absorber to be called as a metamaterial, we have to ensure that either one of these parameters produce the negative values, whether we have a negative permittivity or negative permeability. Okay, the lower the negative values, it means the higher capability of the microwave absorber to absorb any electromagnetics. Okay, and this one, because we have these negative values which is not exist in any material, okay, even in the green material, even in the agriculture waste material, because we are computing this, okay, based on the theoretical formulation, and also the refractive index is negative. Okay, and believe it or not, the metamaterial is actually made of normal copper, okay, or any kind of metal that has high conductivity. And we turn this not into the radiating element, we turn this into the absorbing elements. Okay, so how we do that actually? Okay, so as we can see here, this structure, okay, so this is what we call as a resonator. And to have a metamaterial, you will have one unit cell, and also it will be duplicated to become an array of this set of unit cell design. And this resonator has a very unique feature where it has the capability to absorb, and this is actually the not an inductor but the capacitor. And when we go back to the theory of the solar panels and so on, and of course we are wondering how the solar panel has the capability to absorb the solar power and turn into the electric. And the same concept of the solar absorbing the electromagnetic and you can store this. Okay, so the concept of solar power is a capacitive values and similar with a metamaterial. And the good news for this metamaterial, besides being the absorbing material, you can also use this metamaterial feature to harvest the RF energy around our environment. Okay, so that will be the futuristic of the metamaterial. Okay, and these are the example of the microwave absorber made from the metamaterial. Latest, actually, this is a recent research that has been published. Okay, the water droplet, and here as we can see that the metamaterial are composed with a pepper, with a pad is the polymer based material, RF4. Of course, we are familiar with the RF4. RF4 are widely being used for the PCB electronic devices, and it also can be composed on a glass. Okay, and the second one, the revolution of the metamaterial microwave absorber is it can be made flexible. It means that you can bend, you can stretch, and regardless of this deformation, the performance of the microwave absorber is maintained. Okay, so that's the beauty of this microwave absorber. We do not go for the rigid absorbing materials, and now people are start producing flexible absorbers. Okay, so now we move to the third types, which is our interest. Okay, because this is related to the green technology. Okay, so we would like to turn the waste into wealth. Okay, we want to recycle all the agriculture waste into something which is useful to our industry, to our society, and to the world. Okay, so these are the examples of the green material based composite absorbers, and instead of developing the microwave absorber using the synthetic expensive materials, we develop the green material from the rice husk and also sugarcane bagasse. So this is from our team, and surprisingly, the performance of this green material based absorber are comparable with the commercial microwave absorber. So as we can see here, these are the list of the some of the available green based microwave absorber. Okay, so this is our paper in 2017 from rice husk enforced with a carbon nanotubes, multi-layer targeted, where we can get a reflection loss better than negative 20 dp. Okay, the lower the reflection loss is, the better the absorption characteristics are. Okay, so from this study, it has been proven that a green-based microwave absorber has a huge potential to be used and also to be commercialized as a microwave. Okay, so now we move to the second part of my speech for today. Okay, so I would like to brief on the background of the wireless body array networks, which is also one of my expertise area.
Sudah.
Okay, so I have
Excuse me, Prof. Hasliza. I'm
Yes.
sorry for interrupting. I still have for about 3 minutes left. Thank you.
Okay, all right, thank you. Okay, so these are the wireless body area networks where we have series of on-body sensors. It is communicated on the on-body, and then we transmitted the data into the off-body communication, such as the base station and also access points. And this one will be transmitted to the health personnel and also emergency services. Okay, so these are the wearable flexible antennas which are available in the literature. Okay, so they most of them are using the poly-based material for the absorbing materials. And this is the flexible wearable antennas that are using the PDMS. So PDMS is the polymer base also. Okay, and these are the nanocellulose based composite material which are derived from the agriculture waste. Okay, and so this is the how we produce the nanocellulose base. Okay, so from the raw pine cone, and we do some of the chemical processing, and the cellulose nanofiber films will be look like transparent paper, so it's very thin. Okay, and these are our current research where we take innovative steps to process the coconut fiber core. It's a sabut kelapa in Indonesia language and also Malaysia language, and we grind it, and this is the powder in terms of powder form. Okay, so our target is to produce the ultra thin meta material micro absorber that use sabut kelapa, and so these are the design of the ultra meta material, and you can read our paper, our recent paper for the ultra meta material microabsorber. Okay, so instead of using the coconut coir fiber, we can try for the rice straw, rice husk, sugarcane bagasse, banana leaves, and so on. Why? Because all of these agriculture waste have high carbon content, and high carbon content is actually the main factor of the high dielectric properties. Okay. So these are the result. We are able to achieve the 90% absorption, which means that has a very good absorbing capability. And these are the future direction of the microwave absorber, starting from the bulky microwave absorber and rigid antenna, move to the metamaterial and green composite, and we move to produce the ultra thin nanocomposite materials, which are very useful for a lot of applications such as radar and also the liquid chamber measurement setups, and in fact for the electronics electromagnetic compatibility devices also. Okay, so these are our latest publication in ICIASGA Q1 impact factor 3.745. So for those who are interested with this future research, you can read our paper. And with that, thank you very much. So if you have any further question, you can contact me. I'm head of bioelectromagnetics under Center of Excellence with the Faculty of with the Faculty of Electronics Engineering Technology. So you can email me. Thank you.
Thank you so much, Professor Hasliza. What an insightful talk about electromagnetics. So now we move to Q&A session. So for these sessions, please for the all of the audiences, if you have any questions, unmute the sound and tell me your name and where are you from before you ask. And for this session, we open 3 questions for Professor Ahsan Kalam, and then Mr. Ahyukai Sarindra, and also for Prof. Hasliza. For all of the audience, if you have any questions, okay, please turn on the camera so we can see your face. And if you move or wave your hands, we can see it from here. Okay. Questions from Let me know your name first. Bu Hanifa. Yes, okay.
Let me introduce myself. My name is Nur Kumalaningrum. I'm from State Polytechnic of Madiun. My question is for Mr. Akhtar Kalam. In a conventional power plant, such as hydro or steam power plant, we have spinning rivers as backup energy when an excessive load into our power system. My question is, what is a spinning reverse in a renewable power generation, and how smart grid mechanism controlling this excessive load? Thank you.
Thank you.
Thank you very much, for your wonderful question, Hanifa. Now, to answer your question, the control links are very smart, and it'll detect any overload situation. And as soon as there is an overload situation, there is either few possibilities that can happen. One is that it can ask you to operate in islanding mode, that will disconnect you from the main supply, or the other would be to share with other people. Nowadays, a lot of things like huge amount of neighborhood power is coming, so maybe you'd be able to direct the power directly to your neighborhood system. There are a lot of opportunities, Hanifa, where the control system is smart enough to move very quickly and without any issue to the customers. Am I clear to you, Hanifa?
Yes, sir. Yes.
Do you want to add another question? No, thank you, Bu Hanifa, and also Professor Akhtar Kalam for the answer. Another question for the from the audiences. Agus, okay. We have another question from Pak Agus. Okay, Pak Agus, you may say your questions.
So, did you hear my voice?
Yes, we can.
Okay, thanks. So, actually, I'm very interesting with presentation of Professor Wahyu today, because it's related with my research about vibration machining. So last time we know that Professor Wahyu told us about intelligent policing process, and I know that he now already lead this conference. So question, maybe you can deliver my question to him. So when Professor Wahyu were conducting experimental tests on intelligent policing process, so where did he put the vibration sensor? About it is very important to measure the response of machine. I think that's all my question.
Okay, so the question for Professor Wahyu Kaisarendra, it's about where did he put the vibrations? Am I right, sir? Yes. Or maybe as he left the forum, you may type the questions in the live chat, so we can deliver your questions to him, so he can respond to your question in the live chat. Is that okay, Mr. Agus?
Okay. Yes. I see. So I will type my question, and you can deliver my question. Thank you very much.
Okay, great. Thank you so much, Mr. Agus, for the questions. We will make sure that he receives your questions and he can answer it. Another questions from the audiences? Another questions? No question. Let me check. All of the questions. Okay. That's all. No more questions from the audiences. I think it's a big chance for all of you to ask questions related to the topic that they had already delivered. Okay, no more? No. Okay. Okay, thank you so much for all of the keynote speakers. For the audiences, maybe we can give applause to all of the keynote speakers. What a great presentations. Okay, thank you so much for all of the audiences and all of the keynote speakers. So now the next section for attendees, please break for prayer and lunch until 1 p.m. and followed by parallel sessions. And before we end these sessions, I think it's not enough if we do not take some pictures. So for all the audiences and for all the keynote speakers, please kindly turn on the camera so we can take a screenshot together. Okay, for all the audiences and the keynote speakers. Okay, on camera. Okay. Okay, we are going to take the picture, screenshot. Okay, 1, 2, 3, smile. One more. 1, 2, 3. Thank you so much for all of you, and hope you enjoy the conference. And do not forget to join at 1 p.m. And one more, please, for all the audiences, one more, I remind you that you have to check the attendance list. So the attendance list will be distributed 2 times. And after this opening ceremony, during the presentation of the keynote speaker. So after this session, you have to check the attendance list, and last in the parallel session. Thank you so much.